you? Okay, we are doing BCD to XS3 code converter using sequential circuit. When we talk about sequential circuit, means we have to work with respect to state graph, state table and flip-flops. So today we will be seeing the state graph first for the conversion of BCD to XS3. Later we will see that this makes a very complex and big state graph. So we should have capacity to reduce the state graph also, so that we can simplify it and make the design the sequential state machine using any flip-flop. Again, we will be using D flip-flop only here because that will be least complex in terms of the procedure, but of course the equation of D flip-flop will be quite complicated. We will see all that. What we are trying to do is we are trying to convert BCD to XS3. So for that you should see what do you mean by BCD to XS3. This is your truth table for BCD to XS3. You have a 0 and XS3 means you simply add 1. So output becomes 0, 0, 1, 1. When you have input of 1, 1 plus 3 is 4. So output of XS3 is 0, 1, 0, 0. Same way, if you have input of 2, 2 plus 3, you get a 5. So 3 you have, 3 plus 3 you get a 6. So output is 0, 1, 1, 0. Same way we carry on. 4 will give you 7, 5 will give you 8, 6 will give you 9, and 7 will give you 10, and 8 will give you 11, and 9 will give you 12. So this is a complete truth table of BCD to XS3. If we do a combinational logic of it, we can simply make the output Z0 in terms of B0, B1, B2, B3. Same way Z1 in terms of B0, B1, B2, B3. So that is a combinational logic. But here we are doing a sequential circuit. So what we have seen, the first thing is the output changes. T0 is just the complement of T0 of X. So when the input is 0, output is 1. How we are showing that in the state graph? This is my first state to start with, and the conversion is shown for T0 from A to B and A to C. So input is X, output is Z, it is shown here. So what it shows now is when input X is 0, output Z is 1. When input X is 1, output Z is 0. Now, when you see that first possibility of T0 over, next what do you have? We will show the various possibility here now. I will try to depict here. Now you can see that if T0 and T1, so when if I have 0, there is a possibility that before that I may have a 0, and if I have a 1 here, there is another possibility that I may have a 0 here. Third possibility is I can have like this. So when I talk about your X, when I talk about your input, it's like this. When I talk about your output, how it changes, you had seen that 0 gives a 1, 1 gives a 0. Same way, you have a 0 gives a 1 and 1 gives a 0, right? Now, what you can see here is, if T0 is 0, T1 is also 0, what will come here? I am talking only about T0 and T1. I am talking only about T0 and T1. So you know that the LSBs only play the role. So if it is a 0, 0, when I add a 3, it becomes 1, 1 here. But if it was a 1 and then if I add a 3, it becomes a 1 plus 3 is 4, right? I hope you people are understanding. 1 plus 3 is 4, and 4 means T0 and T1 both will be 0, 0, and that 1 will go to T2. Coming back to 1, 0. 1, 0 is your 2 here. 2 plus 3 is what? 2 plus 3 is What will be T0 and T1 for this case when you have 1 and 0 as input? 2 plus 3
0
is,
and 1.
yes, 2 plus 3 is 5. And what is 5? 5 is 101. When we have 101, 1 will go to T2 and 0 and 1 will be left with T1 and T0 here. Same way, when we have a 3, when we have a 3, 3 plus 3 is 6 and 6 is made by 0, 1, 1, 0. So last bit will be here as 1, 0. Now, whatever is happening between T after T naught, that will be depicted here in these four possibility. You know that if I have only one bit, I have two possibility. So either T naught can be 0 to 1 or 1 to 0. So that is why the state graph showed two possibilities with T naught. But when we talk about T1, you can see that there are four possibilities. Why four possibilities? Because I have four possibilities with the two bits. So now you have to be very careful to understand how the graph is flowing. How the graph is flowing. Now you see here, after, if my T naught is 0, if my T naught is 0, after that it can be a 1 or it can be a 0. So when I talk about T naught being 0, I will be seeing which rows I will be seeing? I will be seeing T naught equal to 0 means I will be seeing this one and this one. Can you see? Why I will see this one? Because in both the cases T naught was 0. Now let me see for this T1. So you understand that after 0, after T naught 0, if T1 is also 0, then I will come for this case, and this says that T naught 0, T1 0. So what do you think should be the output here? What should be the output here?
1.
1. Why output is 1 here? Because I am talking about this case. So in this case, when T naught was 0, T naught was made 1. So X T naught was 0, Z T naught was made 1. Now if I say X T1 0, Z T1 is 1. So X T1 is 0, left hand side of the bar, and right hand side will be showing me a 1. So my first, this blue arrow part I have done. Now let me see the next blue arrow part. Next blue arrow part says that T naught was a 0. Now X T1 is a 1. So X T1 is a 1. So I will write a 1 here. And as you have already told me, you can tell me what should be a 0 here. It is a 0 then 1. So this is 0 and then 1. You should see my mouse carefully here, okay? So if X T naught 0, X T naught 1. So what should be Z T naught? Z T naught is a 1 and Z T1 will be a 0. So I will have a 0 here. I hope you understood this. Now in the same fashion, you should tell me what I should write for these two arrows now. What should I write for these two other arrows? You should tell me. Observe.
Mom, it should be 0, 0, 1, 1.
Correct. Very good. Very good. I wanted each one of you to understand this. I am writing here in a green color. Now, T naught is a 1, and after T naught being 1, here this is 0, 1, right? So I will go to this input 0. So when you see that T1 is 0, X T1 is 0, Z T1 was also 0. So I get a 0 here. Same way, when I see that for the other possibility, when your T naught was 1, and when I see that X T1 was 1, Z T1 was also 1. So that is why you answered correctly that it is like this. So now what is happening? After T naught and T1 is done. Now coming to your T2. Now you can see in T2, again there is a not that very difficult case. But because I have a third bit coming into picture, I will have a many How many next state I should have? The one T naught gave me two possibilities. Then these two possibilities gave me four possibilities.
8.
8, because I have now my T2 and T3. So I will have so many possibilities, and we have to make neatly all these possibility so that it does not make our diagram cumbersome. So I am trying my level best to make, and I want you people to see the truth table and tell me what should come for these arrows. Okay, so all of you observe, I am drawing it. I am drawing only the states. You should tell me, understanding that what is happening for each state change. Okay, so I am starting with my 8 possibilities. You people draw along with me so that so I am able to show my 8 states, and you all know that it is from T0 to T1 over, and then till here I will get my T2, and for T3 it will be reset and it will go to the initial state of A after the 4 bits. It will go to the initial state of A after the 4 bit. So that will be taking care of my T3. Okay. Now I want you people to see carefully and let me know what will happen for each one of it, each case. So you need to refer your truth table. For each one, I will write the input part at least. Okay. I will write the input part because we have to see all the possibility, you know. So 0, 1, 0, 1, 0, 1, all the possibilities I will write here. And you should see your truth table and tell me your output. I am writing the input. Right? So all 0, 1, 0, 1, 0, 1 I have written. Now you should refer to your truth table and see, observe your T2 and T3. For that, you also have to see the previous cases. So this one, what it is showing, this first flow, what it is showing? It is showing 0, 0, 0. For 0, 0, 0, what is your ZT2? See your truth table and tell me.
0.
Okay, now let me show the truth table here also so that each one of you understand. I was talking about 0, 0, 0 and output is 1, 1 and this one I don't know. So I will see my truth table. So what it is? 0, 0, 0. Output is 1, 1. I did not know ZT2. So one of you told me ZT2 is 0. So that is how I will write here output as 0. Next, what I have to see? I have to see 0, 0, 1. For 0, 0, 1, what I have? You see here, I have to search 0, 0, 1. This is the case of 0, 0, 1. So for 0, 0, 1, what I have here? I have 1, 1, 1, right? I have 1, 1, 1. So let me see what is happening. 0, 0, 1. I had 1, 1 and here also I will have a 1 here. So I will write a 1 here. I hope you people have understood. This is one of the very important question which is asked in VTU exam. You will see your previous year question paper. So you should know, you can't mug it up. You will have to understand. You have to make your truth table and you have to check it. Now somebody should tell me in the same grounds what should come here. What is this path? This path is 0, 1, 0. Can you see? 0, 1, 0. And for 0, 1, 0, already I have a 1, 0. Third one I need to search now for 0, 1, 0. So let me see. For 0, 1, 0, what I have to search. Here it is. 0, 1, 0. For 0, 1, 0, I already have 1, 0 with me. And the third bit is what? A 1. So I will be able to make for that. So I will get a 1 here. Right? Any doubt in this? Next, what I will do is 1, 0. You see this full flow you have to see. 1, sorry, it is 0, na? 0, 1, 1. I need to see for 0, 1, 1. For 0, 1, 1, I already have a 1, 0. So it is 0, 1, 1. So let us check. I have a 0, 1, 1. So I need to search. Here it is 0, 1, 1. For 0, 1, 1, what I am getting is 1, 1, 0. It is
No, ma'am, it's 0, 1, 1 is T naught is 0.
for 0, 1, 1, T naught is a 0. For 0, 1, 1, output is 1, 0, 0, right? Correct. So 0, 0, 1, 1, 0, 1, 1. So it is 1, 1, 0. So already I have 1, 0. I have to make here a 0.
Aren't you supposed to read from right to left?
Yeah, it's LSB, ma'am. T naught is.
T naught, we have to see from T naught, T1, T2. So
That will
when
be
I,
0, ma'am.
correct. Let me confirm it. So when I have a 0, 1, 1, I have to see from T naught. So 0, 1, 1. Where is 0, 1, 1? Here, right? 0, 1, 1. For 0, 1, 1, I have a 1, 0, 0. So I have a 0 there, right? So I will have to mark my 0 here. Okay. So on the same grounds, you have to complete all. I am writing the next part here because we have taken care of 2 of the cases. You have to see like this in your truth table. Now, I will also tell you one more method to check it. You all know your BCD to XS3 is nothing but adding 3. So I can add 3 here itself. So what you can see here is when I had a 0, 0, 0, output is, okay, let me take from MSB only. We can verify it. So 0, 0, 0 gave me 0, 1, 1. So 0, 2, 3. Next, I had 1, 0, 0. 1, 0, 0 is what? 1, 0, 0 is a 4. 4 plus 3 is 7. So I should see that. 1, 1, 1 here. 7 is correct. Same way I can check further. 0, 1, 0 is a 2. 2 plus 3 is 5. So I should be able to see 1, 0, 1, 5. Are you able to understand what I am checking? Next, I will see 1, 1, 0. That is a 6. 6 plus, it is 1, 1, 0, right? 1, 1, 0 is a 6, right? So 1, 1, 0, 6. And what is 6 plus 3? 6 plus 3 is a 9. So I can see that I am able to get my 0, 0, 1. 1 is still left. 1 is still left, which will come down to this, right? So now let us go from T2 to T3 now. I hope this part is clear to you. Now, I will use this method only to make the further graph. You will see now, for example, from A to next, I saw 2 outgoing things. From BC to DEFG also, we saw 2 outgoing things. Now, DEFG onwards also, we saw 2 outgoing things. But because after 9, you do not have your 10, 11, 12, 13, 14, 15, we will not see two outgoing things from these cases. Okay, so I will show you how to carry on further. I will make my last case, that is T2 to T3. Now let us observe it very carefully, that for T3, T3 is your MSB. From T2 to T3, T3 is your MSB. So when we see our MSB, I understand from H, I will get two possibility. Why I will get two possibility? Because the input is triple zero. Input is triple zero, 000. So I can have a 0 also, and I can have 100 also. 100 is nothing but your 8, right? 100 is your 8. So you can see here 000 was your input and output was 3, right? So easily I can write here a 0. Why? Because 0 gives me 3 outputs. So left hand side of this bar is your input and right hand side of this bar is your output. So 0000 gave me 0011. So this part is complete. Now let me see the right hand side. Right hand side means it is a 1 here. So 100. 100 gives me what? 8. 8 plus 3 is 11. 11 is written as 1011. So 1 is already there, 0 is already there, only last bit 1 is left out. So I have to write a 1 here. Is this clear to you people what I am doing? Okay, now I finished 0, I finished 8. Now what will happen here? I have a 1 here. So 1 0 0. 1 0 0 is what? This is your LSBs. So 1 0 0 is your 4. If I put a 0, it will remain 4. But if I put 1, what it will become? It will become 1100. What is 1100? 1100 is a 12. I hope you people are understanding. 1100 is a 12, and you all know that 12 is not a valid BCD. That is why I will have only one arrow here. Why only one arrow? Because there is no 12 possible. There is only a 4 possible. So 0 1 0 0 is a 4. 4 plus 3 is 7. 7 1 1 1 is already there. So output is a 0 here. Is this part clear to you people? What I am doing? It is 0 1 0 0 4. Output is 0 111, that is 7. So done. And do you think that J will have 2 outputs? After this you will see J will also not have 2 output. Why J will not have 2 output? Because what do you have behind it? It is a 0 1 0. 0 1 0. And what is 0 1 0? 0 1 0 is a 2. So 0 0 1 0 will give me a 2. And what will give me 1 0 1 0? 1 0 1 0 is a 10. 10 is not possible. 10 is not possible. So that is why J will also have a 1 outgoing arrow only. So what it will be? 0 0 1 0 2. 2 plus 3 is 5. So I can see 0 1 0 1 5. I got it, right? Same way N will also not have. N will also not have, because okay, let me confirm for N also now. It is 0 1 1 0. So what is 0 1 1 0? It's a 6, right? 0 1 1 0 is a 6. 6 plus 3 is 9. For 9, what I should have? I should have a 1 here. 1 0 0 1. So that will give me a 9. So this will be output will be 1, right? Now coming to I. Anybody can tell me what will happen to I? Will I get 2 outputs, 2 arrows or 1 arrow? What you can see here is 0 0 1. 0 0. I am seeing the left hand side of the slash sign. I hope all of you are following me. So left hand side of the slash sign is what? 0 0 1. So it becomes a 1. If I put a 1 0 0 1, it becomes a 9. If I make 0 0 0 1, it makes a 1. So what you can see here is For I should have a 2 arrow, because number 1 arrow will make it as, it will make it a 0 0 0 1. So number 1 arrow left hand side 0 will make it as, what it will make? Tell me. All are sleeping?
0 and 1.
It will be 1 and, see here, okay, you are giving me the output term. Yeah, output, what you told is right only. I am talking about what is the numerical value. So 0 0 0 1 is a 1. 1 plus 3 is 4. 1 plus 3 is 4. So 1 0 0 4 is already made here. Here we get a 0, as you told correctly. Coming to the other one, it is 1 0 0 1 is a 9. 9 makes a 12. For 12 you have a 0 0 already, and 1 is already here. You get a 1 here, which makes 1 1 0 0, that is a 12. Now coming on to MKP, again the way LJ and had only one output, same way M, K and P will also have only one output. Already I have explained well, so I will be just putting the answers here. 0 to 1, 0 0. You can verify it leisurely, you can verify. Okay. Now after your 4 bits of T1, T0, T1, T2, T3 gets over, you should show your feedback back to the initial state. Initial state is your A, and that is why we say that it resets to your state A after T3. So I need to show that from which direction to go back. Okay, I am going back in this direction. This is your reset. Okay, from T3 it will go back to A, that is reset. So this completes only your state graph. This completes only your state graph, and with respect to this state graph, you should see your state table now. Okay, you should see your state table. Okay, what I will do here is I will try to show your state table together. So state table is already made here. Okay, I want you to observe this. Okay, now check this. The same thing whatever we have done here is shown here. Now see, from A it goes to B and C. So from present state A, when x is 0 it is going to B, when x is 1 it is going to C, and your output is also what is there on the right hand side of this slash, right? And it is 1 and 0. So output is shown here. You are well aware with this state graph, right? We have done this many a times. So what you have to observe here is understand the state graph. Once you understand it completely, then we will go for the state reduction table, reduced state table. How do we reduce? There is a procedure for that also. I will explain that. Okay. Now you see here, understand this. T0 is A to BC, output, corresponding output. What is T1? T1 is from B to DF, from C to EG, the way it is shown here. From B to DF, from C to EG. So the same way it is shown here, and corresponding output as you know already. From T2, what is happening? From D, E, F, G, it is going to further H, L, I, J, I, M, J, N and K, P. And because you see output is seen like this, 0, 1, 1, 0, 1, 0 and all. Same way when you go to T3, from all the 8 states, it's going back to A. That is why next state is all A. Can you tell me why this is dash? Why this is dash? So many dash you can see here, no? Why that dash is coming? Yes?
Because only from 0 to 9.
Yes, it is only from 0 to 9. What you can see here is this is a 0 1 0 0 1 0, and if I put here 1, it becomes 1 0 1 0. That is a 10. 10 is invalid. That is why a dash has come. So after this state, all the 1 in MSB here will give me 11, 12, 13, 14, 15. That is why all are dash here. So this is your state table for code converter. I hope it is clear to you how to make the state graph and how to make the state table. Now, before we go into the more details of state reduction, one thing I want you people to observe very carefully is that when it is going to certain state A, you can see so many repetition is happening here itself, here in this side, this MNPJK, and you can also see the output is also same. So we can see that there is some redundant state. Now if you see A to P, the states are A to P. So how many states are there? 8 plus 4, 12, 13, 14, 15. So 15 states means what? How many flip-flop you require for 15 states? Yes, somebody should tell me. For 15 states, how many flip-flop are required?
4 flip-flops, ma'am.
Correct. For 15 states, I require 4 flip-flop. All these days, did you use 4 flip-flops anytime? Maximum you were using 2 or 3. Now, if I can do with this also, but if I try to do with this, the state machine, then it will be a very complicated task. So what do? We try to reduce the state table, and the reduced state table will appear like this. Now, on what basis this is reduced, that need to be explained. That I will explain in the next class. Okay, so our topic for today has not completed. We will continue it, but please revise your state graph and extended state table. Okay.